All right, last two, 7 and 8. We're going to put 7 in slope-intercept form. Remember, it's an inequality, so we got to remember that random rule. Going to get y alone, get rid of this x. Bring this down first. These are not like terms. We did not multiply or divide by a negative. We subtracted, but we didn't multiply or divide, so we don't have to worry about this. This symbol stays the same. Remember, this is 1 negative x, so my slope is going to be negative 1 over 1, and my y-intercept is going to be 2. So we have y is greater than or equal to negative 1x plus 2. And this is actually 1y also, but we don't have to put that 1 here. The only reason I put a negative 1 here is because this is going to be our slope. And then our second one is x minus y is greater than or equal to 2. Inequality, fish hooks, random rule. I want to get y alone. Going to subtract x from both sides. Cancels out. This is 1 negative y, isn't it? This is 1 negative x, and this is positive 2. Not like terms, can't combine them, bring them down separately, bring the x term down first, because we want this in slope-intercept form. Now I'm almost there, except I don't want negative y, I want positive y. So in order to get rid of this negative 1, we're going to have to divide every stinking term by negative 1. Negative divided by a negative is positive 1 times y is y. Negative divided by a negative is positive 1x. Positive divided by a negative is negative 2. Remember this guy? We divided everything by a negative number, so we're going to flip him. So the second inequality is y is less than or equal to 1x minus 2, and of course that's my slope, 1 over 1. So negative 1x plus 2, negative 1 is down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Because of this right here, it's a solid line. And because it's in slope-intercept form, and greater than is above the line. And remember, be generous with your shading. Okay, now this second one starts at negative 2 on the y-axis, and my slope is 1 over 1, up 1 over 1, up 1. Ooh, I see the point of intersection. Up 1 over 1, up 1 over 1, up 1 over 1. Because of this line, it's a solid line, and because it's in slope-intercept form, and less than is below the line. Here's our line. Below the line is here. Pretty easy to see that no shading, single shading, single shading, double shading, both solid lines that border the double shading. So our solutions are on these two lines that border the double shading and anywhere inside the double shading. And of course this shading goes on forever, because these lines go on forever. Is the origin a solution of this system of linear inequalities? No, it is not, because it's not in the double shading. So if I plugged in 0, 0 into both of these equations, In fact, look, 0 plus 0 is 0. Is 0 greater than or equal to 2? No. 0 minus 0 is 0. Is 0 greater than or equal to 2? No. So of course the origin is not a solution, and we wouldn't expect it to be because it's not in the double shading. Last one. Let's go, rock stars. We're almost there. 2x minus 6 is greater than negative 3y. It's an inequality. Fish hooks. Random rule. I want to get y alone. Divide by negative 3 every stinking term. So we have 2 over negative 3 times x. Negative 6 divided by negative 3 is positive 2. And over here we have a negative 3 divided by negative 3 is 1. Why? But we divided by a negative number, baby. So guess what we're going to do? We're going to flip this little guy over. So now he is less than. But now we have to put this over here and this over here. So we're going to put our y here. We're going to put our negative 2/3 x and our plus 2 over here. Now let's think about this. Let's go over here. Is 7 less than 20? Yes. If I flip this over, is 20 less than 7? No. 20 is greater than 7, isn't it? So if I flip an inequality over, I also have to flip its symbol over. So all I did was put the y here, put these two terms here, but I got to flip this little doggy. There we go. So there's our first inequality. Y is greater than negative 2/3 x plus 2. Y is greater than negative 2/3 x plus 2. And now we got one more to deal with. This one looks pretty simple. Hello? Dogs are ready? Thank you. Bye. Sorry, gotta go get my dogs at the groomer. We'll finish this real quick. Okay, negative x plus 3y is greater than or equal to negative 9. I want to get 3y alone. It's an inequality. I'm going to add x to both sides. Cancel 3y greater than or equal to x, and that's 1x minus 9. Divide every stinking term by 3. Don't have to worry about the random rule because I'm not multiplying or dividing by a negative number. Y is greater than or equal to 1/3 x minus 3. Y is greater than or equal to 1/3 x minus 3. So now we're going to graph these two little puppy dogs. Start at positive 2 on the y-axis, down 2 over 3, down 2 over 3, up 2, back 3, up 2, back 3. Broken line because there's no equal sign. Oh no, the line is broken. That means no solutions can be on this line because it's broken. And greater than means we're going to shade above the line generously. And if y is greater than or equal to 1/3 x minus 3, we're going to begin graphing at negative 3 on the y-axis. We're going to go up 1 over 3, up 1 over 3, up 1 over 3, up 1 over 3, or down 1, back 3, down 1, back 3. It's a solid line. And greater than is above the line. shade generously. Okay, here's my point of intersection. There's no shading here, single shading here, single shading here,